Hey guys, today we're going to be talking about the distance of line segments. So it's important for us to realize that whenever we first start talking about line segments, we're talking about them in pretty much a one-dimensional space. We're not talking about, what's their x coordinate, what's their y coordinate, how far up, how far over. We're not that complex yet. We're just focused on this line segment right here, independent of space or time, just talking about length. Now, we're not going to be talking about line segments in the thought of it starts at 0 and it goes to 10, how long is the line? We already know that. We don't need to have instruction over that. What we do need to start looking at is talking about line segments in the sense of how they are constructed and how we can use that construction to form equations and learn about missing variables or segment lengths. Now, there's a lot of different ways you can do this, so we're not going to be able to get all of it in one video or even a couple videos. But I want us to be able to try to generalize this information and use it for whatever problem we're faced with. So here's what I want us to think. I have this line segment here, and I have a point B somewhere in the middle. Now, technically, we actually have 3 line segments that we're looking at, right? We have line segment AB right here. I'll label that line segment AB. We have line segment BC right here. And then this whole thing is line segment AC. Now, we can actually construct some theoretical equations using these line segments. That may sound weird, but we can quite literally write an equation based on how these line segments relate to each other. Here's what I mean. If this entire thing is A and C, and it's made up of the part AB and the part BC, then couldn't we write line segment AB plus line segment BC equals line segment AC? I mean, that makes sense, right? This larger segment is made up of these 2 smaller ones together. Now, you could actually extrapolate that and make some other equations too. You could say, well, if we just want to have AB, well, AB is the entire thing without BC. Maybe you could say AC minus BC equals AB. There's a whole lot of different ways you can do that. What I want us to do now is I want us to talk about a little bit of vocabulary that goes along with line segments, and then we're going to put this into use when talking about actually solving some problems that I'm going to put on the board here. So let's say that B is a midpoint. Now, midpoint is the term we're going to be talking about, but I also want to talk about a synonym for midpoint, another word that means the exact same thing that you may also hear, and that is that B bisects the line. This means that B isn't just somewhere in the middle, but B is the middle, the exact center, right? Now, whenever you have a midpoint, it quite literally means that it splits that line segment into equivalent halves, saying this is the exact same as this, at least in terms of distance or size. So that is what a conclusion that we can draw whenever we hear something like B is a midpoint or B bisects the segment. Again, those two mean the exact same thing. So if we understood that this is true, then maybe this isn't the only kind of equation we could create. Maybe we could also say line segment AB is equal to line segment BC. Now, if we didn't know that B was the midpoint, could we make that statement? Could we say this in all of the cases? No. We have to know that B is the midpoint in order to say that. But when it is, that's an important thing to remember. Of course, the letters might be different, but you can make them match whatever problem you're working with. All right, let's get into an actual mathematical problem. We're going to keep in mind that B is the midpoint and B is a bisector. So I'm going to leave that just like it is. Let's say AB is equal to 15 units, and then BC is equal to 3x minus 3 units. And the problem might want you to say, well, what is x? How would we do a problem like that? Well, we want to ask ourselves, with the information we have, we know what A, B, and BC are, and we know that B is a midpoint. Can we form an equation that will relate these two segments together? Well, we said earlier, if we know this is a midpoint, then we know these are equal. So I'm going to take that thought, that idea, and turn it into an equation. It's an important skill that we have to kind of master a bit, or at least become comfortable with in geometry, is making sure we can take that concept, that thought, that these are equal, or whatever thought you may have, and write an equation with that information. AB equals BC. Now that I've created this equation based on my given information, I can substitute in what they're equal to. AB, well, that's 15. And BC, that's 3x minus 3. Now I can solve this just like we would an algebra problem. Add 3 to this side to get those to cancel out. Get 18 equals 3x, and then get x on its own by dividing by 3. And guess what? X equals 18 divided by 3, or x equals 6. There we go. We found x. Now what if this wanted us to take it one step farther? And it wanted to say, well, what is AC equal to? Could we figure that out? We could. We actually have multiple ways of figuring that out. Here's one way we could think about it. We could think with the equation that we made earlier, that AC as a whole is made up of AB and BC. Okay, now we know AB is 15, and I mean, we know BC was 3x minus 3, but does that really help us? No. But what we could do, now that we know x is 6, we figured that out already, is we could write this with 6 involved. So 15 plus 3 times 6 minus 3. Well, order of operations tells us we got to do 3 times 6 first, so that's 18. So 15 plus 18, that's 33, and 33 minus 3, guess what? That's 30. That's our value of AC. Now you may be thinking to yourself, there was a lot easier way to go about that. There was a lot easier way to figure that out. I mean, that worked. But we could have done it a little easier. And you're right. If we know B is a midpoint, B cuts it in 2 equal halves. If we know the length of one of them, then guess what? We know the length of both, right? If we know this is 15, and that's a midpoint, we automatically know that's 15. So the whole thing must be 30. Exactly. Now, like I said before, there's so many different ways you can have problems like this. So many different bits of given information, and so many different ways line segments can be constructed. Honestly, a lot more ways than you probably would expect. We can't cover those all here, and probably not every question you may have is going to be able to be answered here. But we are going to have an additional video going over some other examples that I think may help us out a bit. If you have any specific questions, please drop them in the comments below, and I'll do my best to get back to you and help out with those. Otherwise, thanks for watching, guys, and I'll see you next time.